So this is just a video to go over a question from the homework from the section about the z-test. So we have here, many people believe that the average number of Facebook friends is 338. This is sort of a hypothesized mean, all right? So I'm going to put it down as mu 338. The population standard deviation, okay, this is really important because this is my sigma. I know the sigma is 43.2. And now we're going to take a sample. The sample is just 50 high school students, and their X bar is 350. They ask me, was alpha equals 5%, determine whether there is sufficient evidence to conclude that the mean of the friends is greater. Okay, so first of all, before I even begin, what kind of test am I grabbing here? Well, these things are telling me my parameter is mean, and I do have the population standard deviation, so I'm going to run here the z-test. Okay, second thing, what is given to me here essentially is the fact that I'm asked about the mean being greater. So when I'm setting up my null, okay, that would mean the status quo is that it's 338, okay? But the alternative is the mu is greater than 338 because they told me greater than 338. So this is also my claim, okay? Remember, I can only, even though that my claim is the alternative, I'm only testing the null. My null hypothesis is that it is the status quo. All right, if I have this and I know it's a z-test, I can run here two things. I can do here the critical value, okay, which is looking at a number line, or I can do the p-value. So the critical value here, my cutoff value, because this is going to be a one-tail test, right? This here tells me that it's a right tail, and this is 5%. So the value is going to be 1.645 or rounded to 1.65. This is my cutoff value. This is the critical z-score. Okay, now, in order to figure out where my test value ends up, I need to calculate my test value. So z is going to be equals to the observed value, 350, okay, or the x bar right here, minus the hypothesized value divided by the standard error, which is going to be 43.2 over the square root of 50. Okay, let's calculate that real quick. Okay, we put it all into our calculator and we end up with 0.327. So let's put 0.33. Okay, so where does this end up? Let's find it. This is going to end up essentially on this side. So here is my 0, okay? And this is 1, so the 0.33 is going to be closer to here. So it's going to be over here. Okay. Did it make it into the critical region? Is it in my critical region? No, it didn't. It did not make it through the threshold. It did not make it into the critical region. So I am not able to reject. Once I compare this, I fail to reject the null. Okay. And the outcome of this is essentially going to be there isn't sufficient evidence. Okay. So because my claim is over here, my claim is in the alternative, I can't take the alternative because the status quo holds. Okay. There isn't sufficient evidence in support of the claim. Evidence in support of the claim. And that's all we have to do here. Okay, so find what you have. This is the most important thing because it makes a distinction between a z and a t-test. And then just use this business through your process of stating your hypothesis and finding the tail and then just calculating your z-test here. All right.